Here we are with the mid-chapter 7, exercises 34 through 39, rationalize the denominator. So again, we're trying to get rid of these square roots in the denominators. That's what we gotta get rid of. Because as long as the square roots of numbers that aren't perfect squares are in the denominators, they are irrational numbers. So we got to times them by something. We have fractions, so we can times the top and the bottom by anything we want as long as we times by the same thing. And remember, these are binomials, so we can't just times by themselves 4 plus square root of 3. That'd be nice, but it doesn't work. We get left with middle terms because of all the distribution. So we have to be careful and look at the conjugate. And let's put that up on top. Conjugate. So these are the things where if you have like 2 plus the square root of 5, you got to times it by 2 minus the square root of 5. A plus b, a minus b from chapter 5 gave us a difference of squares. So it'll square the front, square the back, and leave no middle terms. Genius. So this one we would times by 4 minus the square root of 3 over 4 minus the square root of 3. So the top becomes 7 times 4 minus the square root of 3 over 16 minus 4 square roots of 3 plus 4 square roots of 3. There's the magic happening. And then minus the square root of 3 times the square root of 3 is the square root of 9, which is just a 3. Those two go away. And we have on the denominator 16 minus 3 is a 13, which will not cancel with that 7. So we can just jump it in and we get 28 minus 7 square roots of 3. Oh, that's pretty. Doesn't look like a simplified fraction, kind of looks the same, but that's with the denominator being rational and is listed as a simplified fraction. All right, over here, the conjugate of 6 minus the square root of 5 would be 6 plus the square root of 5. So times that guy, 6 plus the square root of 5. There we go. So we have 5 times 6 plus the square root of 5 on the top. On the bottom, 6 times 6 is 36 plus 6 square roots of 5 minus 6 square roots of 5. And then minus the square root of 5 times the square root of 5, which is 5, the square root of 25. All right, those guys go away. 36 minus 5 is 31. It's not going to cancel with that 5 for simplifying purposes, so we can just jump it in. We get 30 plus 5 square roots of 5. Or if you left it out front as 5 times 6 plus the square root of 5, that would be okay as well. Number 36. The conjugate of this would be 3 minus 2 square roots of 3. 3 minus 2 square roots of 3. So the top is 2 times 3 minus 2 square roots of 3. Good. Over on the bottom, we get 3 times 3 is 9. Minus 6 square roots of 3. Then this guy jumps in. We get plus 6 square roots of 3. Guess we technically should put parentheses around these things that we're multiplying. They're binomials altogether. And then the last one is minus 4 times the square root of 3 times the square root of 3 is the square root of 9, which is just a 3. So these guys go away. That's the magic of conjugates. 9 minus 12 just gives us a negative 3 on the bottom. So this guy can jump in. 6 minus 4 square roots of 3. Now you can take this negative out front or put it up on the top. So you might get negative 6 plus 4 square roots of 3 over 3 like that. Or the negative could come out here in front. And all of those are the same and equivalent and all simplified. All right, number 37. The conjugate of 5 minus the square root of 13 is 5 plus the square root of, oh, did I say 13? 17. And let's put parentheses around that guy. We're timesing by a binomial here. 5 plus the square root of 17, that's the conjugate. So when we times the top, we get 5. 5 plus the square root of 17. On the bottom, we get 5 times 5 is 25 plus 5 times the square root of 17 minus square root of 17 times 5 minus square root of 17 times square root of 17 is 17. So that guy's gone. That guy's gone. And 25 minus 17 on the bottom, that's an 8. 8 will not cancel with that, so we can just jump it in or leave it as 5 times 5 plus square root of 17. Good. Number 38. Conjugate is 5 minus the square root of 7. 5 minus the square root of 7 times the top. We just have 3 times that binomial. I guess we should put the parentheses around there. 5 minus the square root of 7 over 5 times 5 is 25 minus 5 square roots of 7 plus 5 square roots of 7. The magic of the conjugates right there. Minus the square root of 49, which is just 7. And so we get, 25 minus 7 is 18. That will cancel, so I'm not going to jump that 3 in just yet. The 3 and the 18 will cancel and leave us 6. So we'll get 5 minus the square root of 7 over 6. There we go. Now, if you had jumped the 3 in, you have to kind of factor and see, can each term cancel with that 18 in some way? And yes, there would be a 3 that would come out of both terms, so you'd be able to do that. All right, and the last one, number 39. Conjugate is 4 plus 7 square roots of 7. So times that on the top and the bottom of the fraction. Isn't that powerful? When you have a fraction, you can times top and bottom by anything you want to manipulate it to get rid of the denominators with radicals, get rid of the radicals in the denominators. So we have 3 times 4 plus 7 square roots of 7 over 4 times 4 is 16. 4 times 7 square roots of 7 would be 28 square roots of 7 minus 28 square roots of 7 minus 49 times the square root of 49, which is a 7. Magic of the conjugates right there. Difference of squares, so we get 16 minus 49 times 7 is 343. So 16 minus 343, that's 327. Now does 327, let's check, 4 plus 7 square roots of 7, let's write this down, 327. Does that 3 go into that? 3 goes into that 109 times. Huh, wouldn't have known that. Interesting. 4 plus 7 square roots of 7 all over 109. Good.